Good afternoon. I'm James, Chief Technology Officer at Ocado Technology. It's a privilege to be here with you today, and I want to tell you a story about an exciting robotics migration project. So a bit of background. It was 20 years ago that Ocado made its first grocery delivery out of a small temporary warehouse north of London. Today, it could be easy to forget the humble beginnings of online grocery. Back in the early 2000s, delivering groceries in a way that was profitable and sustainable was considered an unsolvable problem. Grocery is fundamentally different from other retail segments. The food needs to be kept at the right temperature throughout the journey to the customer. Freshness is crucial. Customer baskets are large and margins are razor thin. So Ocado started off as a pioneer in this online grocery space. We've been on a hell of a ride since then. Our first generation warehouses relied on a system with kilometers of conveyors carrying thousands of containers. We then completely disrupted that model, and today we have highly automated grocery fulfillment warehouses that are the most advanced in the world. As we've followed this journey of innovation, we've grown and evolved into a global technology company. We provide end-to-end platforms for smart grocery online to some of the world's largest and most innovative retailers. So a cloud-first approach has played a key role in our ability to scale out globally and achieve efficiencies that set the bar in the industry. I'm going to give you a glimpse today of one of the really exciting transformational journeys we've been on, which is moving the orchestration of our fleets of bots onto the cloud. So at the heart of our model are automated warehouses, which are the most advanced of their kind in the world. These state-of-the-art facilities incorporate cutting-edge automation, robotics, and control systems. Thousands of bots collaborate seamlessly on three-dimensional grids to move totes that contain both grocery items or completed customer orders for the most efficient fulfillment of online grocery. The bots move at speeds up to 4 meters per second, and they pass within 5 millimeters of each other. Now, an important point is these bots are not autonomous. They're orchestrated by a proprietary control system and wireless communications technology. So there's an air traffic control type system centrally that communicates with the bots 10 times a second with really low latency so that we get the most efficient and seamless collaboration among the bot fleet. So we get peak performance and the highest throughput at the lowest cost. Now, historically, we hosted our online orchestration system. We hosted it on-site. But in 2020, we took a pretty radical decision to try and move this from on-site to the cloud. Now, at Ocado Technology, we pride ourselves on solving problems no one else in the industry has solved before. We've got a long track record of building almost all the technology in-house. The solutions on the market are generally not fit for the unique demands of grocery. So moving one of our most critical systems to the cloud was a huge decision for us. It's a really bold move. We had to know with a pretty high degree of confidence that we could get the low latency and predictability levels we needed that we had on site replicated in cloud environments. If we compromised either of those two things, we'd compromise the throughput of a site and straight into the profitability of our partners running the sites. So generally, orchestrating a fleet where you've got thousands of bots is a really tough challenge, even with the kit hosted on the site. So the control system receives these updates of the position of each bot up to 10 times a second. It combines that intelligence with knowledge about customer orders and available stock and builds a really meticulous plan of tasks for each bot well out into the future. These tasks are time-stamped with millisecond precision so that the system can orchestrate the bot to its perfect place at any given time in the future. We strive to extract every last bit of optimization and efficiency from each bot's configuration so that the predictability of the plan is a really important factor. It's really critical to that success. And the two big factors there are this low latency of communication from the control system to the bot, but actually also a very predictable messaging delay where we're looking for less than 50 milliseconds delay. If we get variability in the messaging delay, it means we have to leave a larger margin of error into all the calculations. That knock-on margin of error has a knock-on effect on efficiency and throughput that can be really harmful. So as I said, we deployed our orchestration system on local compute in server rooms in immediate proximity to the bots with a really high-speed network straight to them to get this kind of predictability and latency low. That is a great approach for reducing error budgets for the messaging and reducing variation and guaranteeing throughput. However, the cost here is that we need to provide tooling and management systems to coordinate deployments, instrumentation, not only for the applications that are running themselves, but all of the redundancy we need for the quorum-based systems we have supporting them. Essentially, we're running a full private cloud with all the overheads that comes with. So a cloud solution would have to enable low latency and predictable messaging delay every time and all of the time, wherever in the world our retail partners decided to build their next warehouse. We had a good degree of confidence we could get these metrics right for warehouses close to an AWS region. But the open question we had was, what about any locations that were not close to a region? How could we cope with that? So then the trigger for changing our position there was the launch of AWS Outposts in December 2019. The ability to take a productionized rack that AWS used in their own data centers and put them on-prem was an insurance policy we needed. We could guarantee this low latency and predictability even if somebody needs to build a warehouse in a really remote part of the world by leveraging that technology. Not a tech we had to use normally, but it gave us the insurance policy against remote locations. So then, in these conversations we had with our wider team, we looked at trade-offs. We knew it might not be possible to adapt all of our cloud standards and tooling within the time frame we wanted. We wanted a version we'd be happy to deploy into production at scale, even if it wasn't fully complete yet. So then we used our simulation capability and a series of experiments to answer a set of what-if questions, such as how much latency can we actually tolerate between the control system and the bots? How would these systems run in a virtualized environment rather than on bare metal? And we also gathered data about the actual latency we would detect in the real world running these systems. Bringing that data together, we had a detailed characterization, and we could predict the actual outputs. Given at that point we were confident of achieving the benefits, we launched an internal project we called Project Tempest. So we also wanted to use our AWS-based internal development platform that's used by most of Ocado technology to benefit from the sort of knowledge, tooling, documentation, and the economies of scale that come from using a shared platform. The work here was a real team effort across our business. A few examples: the teams that built the bots had to rework their applications and modify their deployment pipelines to work with the cloud setup. Our engineering productivity teams added support for features such as Keyspaces and network load balancers to support the kind of low latency comms we needed between the orchestration system and the bots. And our cloud team helped facilitate a smooth migration from on-premise VPNs through to the cloud. Now, when it came to migration, we started with our largest CSC, Earth. The reason we did that is we needed to prove that this would run at scale. Earth provides more than 10 times the scale of operations of any other grid in the world. Some of our most technically challenging and latency-sensitive services were at the core of the migration, so it was no small feat to move them. We organized a series of trials to steadily migrate critical functions one by one, such as our chill grid, followed by our ambient grid. Each trial meant a database migration to AWS, and then back on-prem. Following that, we did our first migration on Christmas Eve, once all the customer orders had departed and are out on the road. That gave us about 48 hours recovery time if we needed it. So then, piece by piece following that, we moved all our applications and data on a pretty aggressive timeline. Since that migration, there'd be no significant outages or incidents as a result of this change, which is a testament to the planning and execution of those teams involved. So at Ocado Technology, we like to set stretching goals for ourselves, and this was no exception. In just 12 months, we had completely migrated all instances of our bot orchestration applications to run on AWS compute environments, and at that point, we were orchestrating over 5,000 bots from the cloud. Today, this number is nearly 10,000 bots. In the next few years, as we launch more sites across the globe, we'll be orchestrating tens of thousands of bots. So what's next? So in 2022, we unveiled Ocado Reimagined, a series of innovations that are a step change in the technology powering our platform. Our new 600 series bot is the world's lightest and most efficient grocery fulfillment bot. It will let us build lighter grids, saving time and resources. Our new on-grid robotic pick arms are equipped with computer vision and advanced sensing capabilities. They collaborate seamlessly with the bots to pick and pack customer orders. Together, these innovations have enabled us for our next generation of automated warehouses. As we scale, our cloud strategy plays a crucial role in us achieving the highest levels of efficiency in our systems. So thanks for listening. If this quick version of the story sparked an interest, our teams are still hiring. So reach out to me if you want to find out any more about anything I've talked about today. And thanks a lot, everyone, for sticking at it till 5 o'clock.